Hello, welcome Sakthi to today's podcast. Our guest is Sakthi from LeapFrog. If you quite remember, we spoke to one of the co-founders, it's Paul Adia, and then he said he's going to bring to us someone exciting that we can have a good chat with. And here we are today with Sakthi from LeapFrog. Okay, so for those of you, my name is Bernard from Data Pandas. We host sessions with industry leaders um, across the world, so including LeapFrog. So we are excited to have LeapFrog with us today. And the topic for our discussion of our podcast today is going to be around SRE, from reactive to predictive. How is AI transforming site reliability engineering? So without wasting my time, I'll give the floor to Sakthi for him to introduce himself and talk to us a bit about his background and what he's doing with LeapFrog.
Thank you. Hello. Really excited to be here. I'm Sakthi, and I am one of the co-founders of LeapFrog. So my background is I've been in this industry. I've been in SRE, DevOps, pretty much in this industry, even before SRE was a sexy term. I was in this for like a decade now. And then the goal of LeapFrog, or like SRE, to why we are building what we are building now, came from all the frustrations I personally had working in the industry. And I always wished, this is, if I had something that would bring everything together, that'd be great. And obviously over the years, there was these frustrations and pain points of, everybody wants to reduce toil and things like that, which, but there was never a time or like a specific tool that could actually enable this. And obviously, long behold, ChatGPT came around, and then the world turned upside down. And in the last few years is when the technology was mature enough where we can implement AI into this space that would actually solve most of the problems and pain points. And that's what we're trying to build at LeapFrog. And it's a very tough challenge, but that's what makes it exciting.
Wow, amazing. So you actually saw a problem which you were facing in your day-to-day work as a DevOps engineer, cloud engineer, SRE engineer, and then you decided to face the problem head on.
Yes.
Sorry, go on.
No, yeah, it's not like one problem, but like collectively, what SREs do and what the pain points are, how we can make it better. So everything put together came up. We have a big list of things we would love for a dream tool to solve, and that's what we're trying to build.
So you are taking the pressure, you are solving issues with AI. I mean, for companies and for DevOps engineers, SRE practitioners as well. Okay, so you've mentioned the term SRE, right? Like, I don't know. Like, let's say I'm a beginner. Like, I don't even know what the term SRE is. In 1 minute, what does SRE or predictive SRE mean to you in the real world?
Yeah. So I'll answer it in two parts. First, I'll say what an SRE does and why that came about, and then I'll say what the future of how I see that going forward. SRE was a term coined by Google. Like, they formed this term, like everything else there, like the industry leader. So the term was, in the beginning, you had like the big cloud revolution like a decade and a half ago, and everybody moved to the cloud. So what happened was there was initially developers who built the applications, and then there would be like ops people who would run the day two operations, and it was quite siloed. And then the term, once you move to the cloud, there was a need for someone to sit in between. And that's why DevOps came about first. So you have a developer who also knows the ops side, but then DevOps, different companies had different definitions for it. Traditional DevOps started with the guy who only does CI/CD pipelines. He doesn't know anything about it. He just makes sure code gets shipped. And then that was not enough because applications grew complex, cloud, grew, and microservices came about, the whole microservice architecture revolution. So then people wanted to have someone, DevOps engineer, or someone who is also more like a full stack cloud engineer. That's how I'd put it, where someone who knows the code and who can also make sure the code, like let's say if I click on this button, I want this to open. That's a feature a developer would develop. But then if million people click on that button, if the same thing should happen, then that's a different problem, scalability and reliability. So there needs to be an engineer who also knows reliability, how to build the system, to do the plumbing in the back end so that it can handle millions of traffic. So that's how the requirements kept on building. And then Google eventually came up with this SRE, who is like a reliability focused software engineer And that became site reliability engineer in the new microservice cloud world, where an SRE can code, like if a production issue happens, like every second your app is down, lose revenue. So they want someone who can quickly get their hands dirty and also put a hot fix and then fix the code and then make sure it's running reliably as well. And that's how SRE came about. And also Kubernetes was maturing. So Kubernetes and SRE were like hand in hand. And then that's Google's gift to the industry, and that's how it became famous. So that's a long answer to what an SRE is. I hope that made sense to the audience. Secondly, what I see, why now with all the, okay, what does an SRE do? So then an SRE was looking at issues, like they would be on call and then they would see if anything goes down, they would like get on it and fix it quickly to make sure. There's a term called MTTR, which is like mean time to recovery, which is like an industry standard for how long the time taken from when the service went down or when the issue was detected to when you brought it back online. So that time is a metric people use to measure how quickly or how revenue impacting that incident or an problem was. And the goal of an SRE was to always reduce the MTTR. Like even if you can fix it in 2 seconds, that's brilliant, because every second in a big organization, let's say on a Black Friday sale, an e-commerce website, if it goes down for even like 10 seconds, you lose millions. So that's why it became super, super critical that SREs can somehow, this one person who's a know-all can fix it quickly. And the problem with that is what we are trying to address is it was all, until this point, it was all reactive. Something goes wrong, you have all your alerts and everything, and then people scramble and then wake up in middle of the night to fix it. But then what we think is, why do we not have the MTTR in the first place? Why do we have MTTD, which means MTTD is another metric that comes before R, which is mean time to detect. So when you detect, how if you can fix it quickly or even before the problem becomes bigger, if you can contain the blast radius, then the site will never go down. So that's like the $1 million solution where every company or anybody would kill to have. And with AI, I think we can get started on that journey. Again, I wouldn't say what, even at LeapFrog, how that is our long-term goal where we want to predict issues before they happen and fix it. But currently we want to at least start with reducing that MTTR. Instead of 7 engineers trying to make sense at 3 a.m. and taking 2 hours to fix an issue, if we can implement AI, that's like rocket fuel, where it can be done in like 30 minutes. That's obviously value addition in the first place. So yeah, that's how I see it.
Wow, amazing. You've covered a lot in this definition of SRE. So first it came from Google, and then, I mean, how many softwares have Google shipped to us free? We can't tell them enough. So it came from Google, and they said it's more about reliability. So there's a DevOps engineer, there's a developer. DevOps engineer does the CI/CD pipelines, the developer does the programming and everything. But then in between, there should be reliability, like how the system is maintained. And that's where you guys or SRE actually comes in. You did mention mean time to recovery. And I check on your website. I think it's one of the key things that you guys focus on at LeapFrog. So what do you say the best mean time to recovery metric? Like, is it like 2 seconds, like 5 seconds, 2 days, 5 days?
Yeah, well, again, as you said, right, it's not one size fits all. It depends on the application. For example, a payment service in an e-commerce, I mean, e-commerce is pretty easy for everyone to understand, so I'll just stick to that. For example, if your payment is failing, and if, then your entire business is down. So that service would be, so normally in an organization, you set different levels of priorities to certain services because it's all microservices. So if a payment service is going down, then that needs to be fixed like yesterday, or like, even 1 second of it being down is revenue impacting. So that will have a shorter as MTTD. Well, people expect a shorter MTTD. And there's also something called, I feel like I'm throwing jargons here, but this is also another standard metric called SLOs in an organization, where it's called service level agreements and objectives. So that means we guarantee, or like you make sure that this payment service will have an uptime SLO of 99.99% in a month, which means maybe it can have 5 to 10 minutes of downtime. That's the allowed downtime. So even when you go to a cloud provider like AWS, the reason you pay them so much more money that is because they promise reliability. So you don't have to have your server and worry about if it crashes and maintaining, patching, all that. So that's, any cloud provider will give you their any service you use, they will have an SLO we call it 3 nines, 4 nines, dot 999, things like that. So that is the promise of the provider. Every service would have an SLA set, and based on that, any incident that arises from that service would be treated accordingly. So if a service is super critical and it has 100% uptime is like not realistic. People always, you can add more nines to it, but there can never be 100%. So for that, you set up a very high number of nines, like 0.999%, and that has a very low room for error. And then if an incident happens, you have to fix it within 30 minutes. So that dictates how the MTTD should be, and you try to achieve that.
Wow. You thank you for that. You did also mention, and you did talk about mean time to detect. And before I come to that, you made a very good point. You made a point that if a system goes down, it's quite revenue impacting. And I did a quick Google search around how much Amazon makes, in just a minute, and it's mind blowing, right? It's mind blowing. It's about 1.3 billion US dollars. So imagine Amazon system is down, and then you're unable to detect. That means that is a big revenue impact. So with LeapFrog, what can you say, is the big sort of impact that LeapFrog actually makes in organization? We'll come back to LeapFrog in a detail, but just because you mentioned the issue of revenue impartation, I know about revenue is going to be one of the impact, but what other impacts that LeapFrog as a company makes?
So again, that is one of the biggest cornerstones where we try to address, because at the end of the day, people pay for a tool that adds value, and what better value can you add by saving company money and time, and everything at the end of the day translates to money. If you can save more time for the engineers, then that means quicker fixes, which means quicker revenue back on track, things like that. But for us, how we it's not a silver bullet, in the sense, like, that's why I said in the beginning, it's a very hard problem, because systems are very complex. One company software is different from the other, so it's a entirely different ball game altogether. So can't have, that's why it was very hard before AI to do anything with software, because software in general is deterministic. You say if this, then it's always a standard result. But with AI, it's predictive. You don't know what the end result is going to be, and that's why it was the perfect glove for this problem, because every problem in the SRE world, what we're trying to do is not deterministic. I mean, yeah, sure, the same issue with the same microservice, can a fix implemented 2 months ago might not work now, because it's so complex, something internally must have changed. So even on the surface, if it looks same, if you apply the same fix that you did last month, it might not work. So that is why it was always harder to solve this problem with software. And now with AI can adapt and then be predictive and responsive, and then help in solving these problems. And what we try to do is, this is how we imagine, like, this is from my personal story as well. Years ago, when I used to work in the industry, like, I was on call, and then when people get called, let's say you just joined the organization as a new engineer, at least it takes 3 to 6 months for any engineer to kind of wrap their head around the systems, considering if it's a big organization or what. So if you're in month 1, if you're on call, and then you get an alert, a senior engineer might fix it quicker, but a junior engineer, you need to make sense of what's happening, what the service is, and you open 7 different tabs, and all these things while you scramble, it makes your MTTD longer and longer. So obviously it's revenue impacting. And what we try to do is, we want to bring all these context into one place, and then let you make the judgment. So we're not letting AI go wild, but then we are collecting all these logs, metrics, making sure what the blast radius is, what is impacting, giving you wake up, and then you see one screen, and like click a couple of screens, and then in our platform you see everything that you need to know. The context is king here. So once you have the context, then you will be confident to do an action. You could roll back a deployment. If we say this deployment cost this, and then if we can connect all the breadcrumbs and the dots together and give it to you, then you will feel more confident to make a decision and fix the issue faster. So our fundamental ethos is built on that principle, where we want to use AI not to fix every problem. Well, that's the end goal, where we want predictive and then auto fixes and all that. But today, if you ask me, I wouldn't say anyone would be too comfortable to just AI run loose in their production cluster or any environment. So this is what we think will add more value, where we bring everything on a single platter to you, and then let you make a decision faster, and then the business is happy and you can go back to bed.
Wow. That is nuggets in there. You mentioned some good points, which I can relate a lot. Like when I was when in industry, when you're working, particularly this festive seasons like this, and you are scheduling timetables for whoever will be on support or whoever there, you'd want one senior person to be around,
Yeah.
even though you don't really need them, but you are scared that something might happen. But what you guys are doing is that you can actually reliably let these senior engineers even relax whilst you bring the context to whoever is on support, whether junior, mid senior, or mid level engineer, to be able to handle this. And I remember Paul was saying that you guys also do remediation through Terraform and CloudFormation, where you actually create PRs and code suggestions that can be a face for whoever is doing
Yeah.
it.
So we approach it from two angles. So inside out is our strategy where we build a platform where we do a cloud. We know everything that's deployed in your cloud environment, and then we can track every change that is made internally as well. So if any issue happens and if an alert fires, we can connect the breadcrumbs till the infra layer. Sometimes maybe you made a secure, sometimes someone ran a Terraform and that changed the security group rule. So now all your pods can't access the database or something like that. So if you only I mean, not every issue is related to infra, but then what we have is we have an advantage of even knowing the infra level changes. So we can give you more context when an issue happens and then tell you this could have been the reason or this is why. It's higher confidence in the more context you have. Like, yeah, if you know the code base, you'll know what is wrong in the code base, is a stack trace. But issues are far related to not just limited to code. There could be DNS, external factors, infra changes, everything. So that's what we're trying to build, like an intelligence platform on the cloud, so which knows everything. And context, the more context you have, the better AI will be good in fixing those issues.
So the more context you have, the lower your MTTR and the lower your MTTD. All right, so let's move on. So what is the most common pattern that you see teams stuck in terms of when they are doing reliability? The one I want to ask is, what's the most common pattern you see teams stuck in when reliability is very reactive?
Again, reactive always has a problem of every, like, there's always smoke before fire, right? So there's and that's what, again, I'm not saying we are like doing something new or like inventing anything. There all these big boys in the like Datadog and Grafana, they're all like all these observability platforms. They all use, even before LLMs came about, they were using like traditional machine learning to understand and recognize, predict patterns and whatnot. But it's the problem why there is no easy solution, or why it's still there's companies springing up left, right, and center. At least this year, I know at least 3 to 4 companies who've started trying to solve the problem we are trying to solve. So it's always, you can't just use an ML algorithm to say, oh, if this spiked on a Tuesday, the next Tuesday the same spike will happen. No, it's not going to be like that, right? So that's why it didn't go that far, and now everyone is using AI to do it. But in general, in terms of reliability, there's so many aspects to it, because if you don't have a strong engineering channel, like first when you built the app, then fundamentally your app is not reliable and scalable, so it wouldn't scale, or it would break, or it starts from the code. Like, you need to write scalable code, use the best practices and all that, like no excess memory, garbage collection, things like that on the code level. But then you also need to do, next comes the infra level, where you deploy it, like, want to deploy on Kubernetes, like EKS or something, and then Dockerize your containers, make sure your secrets are not leaked, and then there's good security practices and everything. So it's not, security is something which people don't pay much attention to, because they're like, oh, it's just whatever, we'll just security is fine. But then even if you do everything right, if you get like an exploit or someone hacks into your system, and then that, in one of my experience, we literally had like a crypto miner, a package installed that came through the CI, and then that was affecting, we then had to redo the whole production server and then migrate over. This was before, when we were trialing and we were still on EC2, not on EKS. So things like those tells you a lot about how security is important. So there are aspects of these. AI alone is just like, I would say 10%. It's like the tip of the iceberg. But the real value comes in like plain old boring good engineering work. That's like 90%.
Wow. Wow. So you did mention that there's always a ball file somewhere or something. Where did this problem normally originate from? Like this kind of
In terms of reliability, or what problem specifically?
yeah. So like I'm talking more with the infrastructure. I think that's where we're able to detect. I mean, at this stage, more like what LeapFrog is more. So in terms of like an issue that might happen that LeapFrog might detect, or that might be easier for the SRE or the DevOps or the developers to solve fix. Where does it normally start from? It does start from changes or capacity or dependencies or any other place that you think normally these kind of issues start from?
Yeah, the top ones are usually, that's why we try to do like a service topology graph. So where we map everything. The first step in LeapFrog is to first understand your environment. So only when we know what is in there, we can tell you, oh, this could be related. If service B goes down, we need to know if service A and C are dependent on it or not. So that's why the how we approach it when we tie into your environment, we first make sure we scan everything and like we build a mental model for the AI. So then if any metric or any service is complaining, then we can immediately build a blast radius of the services that are related to that. So let's say if a back end is failing, then we can say, oh, the front end might be affected, because then the users won't see the response from the database, things like that. So that in itself, using then AI to give you like a summary that will actually tell you this failed. So this and this depends on that service. So you might want to also check that service for errors. So this is the kind of value we think we can add. And because if you don't have that, these things you have to make up in your mind. Service B, then it's the back end. So I should probably check the Kafka queue or like the front end and the database to make sure it's fine. But if we can instantly show database is all fine, you don't have to worry about that. Just check the backend logs and fix it. So that saves you time. And that's, I think, one of the key values we add. And usually the changes, issues, the source of issues is mostly, well, half the time it would be deployment. Someone deployed something and that triggered a chain event and then that caused this to go down. So if we can connect a person like Bernard deployed this on Friday, and ever since then the CPU has been spiking on the backend pods, and that deployment was related to the backend, then we can easily correlate that, and that one of the fixes for that is like, oh, if you're woken up on a Saturday morning for that, then okay, just I'll roll back his deployment, and then we'll investigate that. So the immediate issue is fixed, and then the next time we'll see why that happened, and the post-mortem and everything comes after that.
Amazing. Okay, let's give some value to our listeners. So let's say somebody in our listeners or the audience, they have a company. It can be a small company or a bigger company, and the team has a limited time, okay, to sort of face something. What is the highest return on investment AI use case? I mean, can be LeapFrog or general SRE principles for them should have to deploy first. I mean, to help them face issues. Is it alert noising, alert noise reduction, or anomaly detection, or incident summarization, or whatever? What do you think be the best way for them to start?
I think it's about, there's two things. Not every alert is an incident. An incident is something when something goes wrong and you need to like scramble to fix it. It's revenue impacting or whatever. Because in general, teams do configure alerts and logs and everything. But then most of the time, if an alert fires, you ask a senior who's been there for like 5 years, he'd say, just ignore it. That service always complains. You don't have to worry about that. So if we can, what we do is we want to triage alerts. So when alerts come in, we want to do that first set of quick investigation using all this AI and all the context, and then tell the user, hey, this is what this is. Again, it's not impacting customers. So then that gives them a peace of mind. Then they can deal with that slower. Or if something is really customer impacting, then we can raise an incident on that and then bring together everyone and do it. So this in itself would be the best value addition, where the quick triaging using AI agents, not necessarily humans dealing with every alert.
Wow. Wow. So not every alert is a noise. Not every alert is an incident, and not every. All right. So you are saying, not in order not to waste time on unnecessary or irrelevant or not production sort of big issue, we should triage the alerts. Know that this one is maybe a very high priority. It can cause production problems. This is not something need to worry about. This is something that we can deal with at least for a day or two. Wow,
Yeah.
that's cool nugget. I think I've taken something. I believe the audience are also jotting down their points. All right. So let's come to predictive capability. So what data foundations must exist before AI can predict anything meaningful? Signal, service mapping, incident history, Like before you go into in a company, what should they have in place before this system can really work?
Yeah, again, this is sort of it's not like a plug and play in the sense. I would say two major things. One is context, which can be like your service mapping. Like the more in depth context it has, the more it can predict. And the second equally important thing is the organizational context. Like, for example, the more our product becomes better and better, the longer we integrate into a partner or a company. Because one of the features we also have is after every incident or an alert investigation, we create something called a runbook, which is like how you dealt with this now and what can be done. This is not a new concept. People have been doing this, but historically, it's like a Confluence document which someone writes a postmortem and nobody looks into it ever again. And it becomes irrelevant in 2 months because there's like 100 deployments to that service. In those 2 months, that fix is no longer relevant. So, what we emphasize on is creating a runbook system that actually people want to work. And that is fed into our database for the AI to be in its memory. So, next time when a similar incident happens, it can automatically suggest steps citing that runbook saying that, hey, you fixed this issue a month ago using these steps and it actually worked. So you might want to try that again. And then if that doesn't work, then the AI can automatically rewrite that runbook with the latest changes you made now. So doing this keeps it a much more, the AI becomes a part of like a senior engineer who is never going to leave your company, but humans do. So this system builds organizational knowledge, and that makes it become better and better at predictive the next time. Like, let's say if it's running for a year, it's pretty much seen 90% of all the issues because issues normally repeat. And then after a year, it would be so much better at predicting stuff that it would say, even before an alert is fired, hey, I see this pattern, which I've seen 5 other times before. So you might, can I implement this fix to make sure it doesn't become an incident? And then that is how we transform from reactive to proactive.
Wow, wow. So you did mention context, and then you did hone into organizational context. I was going to ask you a question, but I think you answered the question yourself. For every organization, context of the organization actually really matters to help the AI to learn and to fix things. And you gradually gather that context and then provide runbooks so that it can always contextualize and deploy and fix things as you move along. So over time, the organization, you have all the incidents or most of the incidents, you have a full graph knowledge of the organization, and then things become very smooth for them. That's brilliant.
Yeah.
So what
Just one point. And the potential of this is not just suggesting being predictive at resolving incidents. It can also, the more it learns, it can also suggest you improvements. In general, it doesn't have to be code based. It's like I've been running for a year, and every time this kind of deployment, it knows every deployment, every code change. It knows a history of how your microservices matured. So it would say, oh, this pattern of deployments or this development using this module resulted in a lot of errors. So in terms of analytics, it's just a gold mine. Like, you could gain so much from it. The more AI learns from it, you can give insights on different departments. In general, it could then suggest you reliable ways of improving those services to prevent issues. So it's not about trying to predict issues from signals, but also suggesting you good practices to improve your logging, metrics, and making sure the service is reliable in the first place.
and LeapFrog provides all this.
Yeah. Well, we don't have everything on production yet, but we are a young company, so we are starting. It's a difficult problem. So currently we are working on the service topology discovery map. And then the next goal, so we have the next quarter, we're going to launch an MVP, and then we have a roadmap set to achieve this state.
Wow. Wow. But you have some of them implemented.
Yeah.
That's awesome. So you did mention predictive, like when you get to know the context of the organization, you get to, use industry standards that you have, best practices and stuff. So what are the best leading indicators that something will break soon? Like, let's say you go to the organization, it takes you some time to build out the context. Obviously, you have the AI learning from around the world when necessary and stuff. So it's probably you have a little bit of a cold start in that organization. So what do you be the best indicators or leading indicators that something is going to break, even though when you have not actually built up the organizational maturity yet? What do you look for?
Yeah, I mean, the organizational knowledge is key to get better at predictive, but we can already see issues. So the first thing is we will be reactive. Obviously, there's no getting around that. Anyone who says, we will plug in and from day one we can be predictive, I always take it with a grain of salt because it's difficult. Yeah, you can. So our system is built where when an issue happens, we come up with like different hypotheses trees for what that issue could be and how to fix it. And that's like the only way where you can do. And that's how humans troubleshoot. Like if you think of an SRE, if an incident happens, you get up, you're like, okay, this is firing. So this could be because of a deployment, or this could be related to that, or this. So you make up different stories in your mind, and then you investigate each of these hypotheses and you come to a conclusion with that, right? So it's basically doing that, but 100 times faster than you physically can do.
Wow. Wow. So you're doing that at scale and with fast.
Yeah.
Yeah, with speed. Okay. So how do you validate prediction so that it doesn't become a box that cries wolf? Like, how do you validate it? Like you said, you mentioned that it comes out with hypothesis graphs, suggesting this and that. How do you of the different hypotheses that the AI comes with, how do you validate them?
So what we do is, I would never suggest an AI that just gives me a one-liner. Oh, I think this is the issue, because we all know how ChatGPT is, like how AI is very adamant in saying that what it says is true. So we substantiate every hypothesis or every step we suggest in our platform. We substantiate it with the metrics or logs or any data we collect as evidence for that. So you click on any hypothesis, it'll tell you this is why I made this hypothesis, because I can see from the logs the deployment was done at this time. So, all those. So as an engineer, when I click on that and see that, and I'm like, oh yeah, okay, that makes sense. Okay, now it makes sense. Rather than just having a one-liner. And I'm like, are you sure? How did you come up with this? So fundamental, everything in the platform is giving user the control and the trust. So we first need trust as a major factor for anyone using an AI tool. So we just interweave that into every aspect in our platform.
Wow. That's awesome. Let's talk about, you just mentioned trust. The moment you mentioned AI tools, people start thinking about trust and stuff. So I know you guys are making great advancements, all this beautiful stuff, and SRE is also, progressing. And obviously with AI coming into the scene, things are moving faster, as you've already explained, as most of the audience also know. So where should AI never be autonomous? Okay, in SRE, like obviously you said, like you can't just leave them to do whatever they do. Like in your case, you create PRs and give suggestions of code fixes and stuff. So at what point that you think that SRE should never be autonomous? Can it be autonomous in some? Can it be ever autonomous? I think that's a fair question as well.
I think yes, and yes, it can be autonomous in certain areas, and definitely not in certain others. So the definite no's would be like production cluster, deploying something, pushing a code base by itself. We are spending hours now trying to fix a problem and implementing a fix. So it would be insane to think that, oh, AI could do 99% of all the work, and finally you be the reviewer and you just hit a button and then the fix is done. So I don't think humans will always have time to do that. And I don't think that will be a major blocker for anyone to fix an issue. And even now with AI coding and everything, like people, right, there's so much code being written. And that's why we are very bullish on this industry, because earlier this used to be a problem when humans wrote all the code. And at least then people can understand what is wrong with the code when an issue happens. Right now, everyone's vibe coding. Like nobody even like knows what it is there. Only when an issue happens, people try to go and see, and everything is new. It's like, okay, what is this code base? What does it do? Because nobody sat and wrote that now, right?
Yeah.
So that is why you need to fight that AI written code with AI to make sense of it and then give you a summary. So if you would be fighting a losing battle if you are manually reviewing AI written code that you've never seen before during a crisis. That's like the worst combination ever. That is one. And production, always do all the toil, take away every toil, let AI do the heavy lifting. And then finally, it's like a very good Jarvis, or like, to use an Iron Man reference, saying that, oh, I've done everything. Do you want me to deploy this or not? And then you just, as a human, you have the final say. And for dev clusters, writing test cases, trying different things, like if you want to load test something or try to break something, you can always let AI go wild and like let do its thing, because it's a contained environment, it's a sandbox, you're not going to break anything. So it's about using your judgment and also being sensible. You wouldn't let a junior engineer play with the production database even before AI. Like nobody would do that. So why would you expect AI to go and do it, right? So it's the same thing.
Also, amazing. You said something that really really stands out. He said reviewing AI written code manually during crisis is like and no. Like
Yeah.
you've never seen the code base before. It was written by some AI tool. And now in the middle of crisis, you're going to use manual human beings to go and review the code which they've never seen before. Now they have to understand the code, then find a fix. But you said the solution is to use its counterpart AI tool, which can understand it quicker and make a fix. And that's what you guys are doing. Amazing. Amazing. So you also said, okay, obviously we don't need to in production systems. It's a no-go area for fully automating. Maybe not now, maybe in the future, and very security sensitive issues to maybe not now, maybe in future. So you still have going to have human beings in the loop. So those of you that are worried that their jobs are going to be taken, see, there's no job taken at the moment. It's going to be AI, you working alongside AI, AI helping you make you better, and you making the AI better. Is that right?
Yeah. And I think it becomes even more critical for humans to be experts now than before AI. I always tell people, like, it's not going to take away your jobs. If you just think your job is just writing base level code as a junior engineer, then yeah, you're going to have a tough time. But then you have to become an expert, like more of an architect in guiding AI. And that's how you become super valuable then. But I think any new technology introduces change and people panic about losing jobs and all that. A funny little snippet I always find fascinating, like in the early 1900s, when telegraph was invented, or like even in the 1800s when calculators were first invented, all the statisticians working in universities protested, saying that they're going to lose their jobs. But did they? Yeah, I mean, they might have lost their jobs, but then humans went on to do other things much better. And then that's how change always happens. Same with internet, same with AI now. So same with any other thing like quantum or whatever that's going to come next. But
Wow, I like that analogy. Okay, so we work alongside AI, and the AI works alongside us. Great. LeapFrog angle. Let's talk about LeapFrog and what you guys are doing. So if a client asks uh, LeapFrog for a 90-day roadmap from reactive to predictive, okay, reliability, what are the three phases that you guys go through?
So first is definitely, yeah, it will be reactive in the sense for all the reasons I've explained before. Reducing the MTTR, that's the main thing people find issues with, because there's no other way of saying that, oh, even if you put 1,000 engineers on a call, they still need 2 hours to understand the system to make sense of it. So it's not a question of you put more people on it and then that reduces time. No, it's not necessarily the case in everything. So the most value addition, what we see from talking to leaders in the industry, our early potential customers and everyone, is that, yeah, if we could reduce that time, it's a quantifiable metric that can easily translate to revenue savings. So that is how we would attract. So we'd go in, do the service discovery, I told you about, map all the services, and then get set up. So when an issue happens, we can give you that first level of context of what's happening in your system, the blast radius, what is affected, what's not, and then giving you all the quick single pane view of, let me check this service logs to see this and make a decision faster, is, I think, is our fundamental value proposition and how we would approach it.
Okay, that sounds a solid roadmap. Okay, so in closing, if a listener wanted to start next week, what's LeapFrog Clouds, LeapFrog 30 to 60 to 90-day path to predictive SRE? What do you do first? What do you avoid?
First, yeah, we already have customers who we've onboarded with configuring alerts, because some people, all we say is, oh, when an alert comes, we'll investigate it. But what about people who are like, who don't even have the proper alerts in the first place? So we even help to do the housekeeping first to make sure first you're generating alerts. So we've onboarded customers where we set up CloudWatch alerts for the infra, and then we can have set of default alerts set up for Grafana, Datadog, whatever you'd like. And most of the tools by default, they come with templates, so you don't have to sit and like write every single alert. So it's just we have a Terraform template or a CloudFormation where it's a one quick install, and that configures all the alerts. Like that would cover 95%, and then we feed that into our platform, and then anytime anything complains, then we can do all the process I described about. So people don't even have to think that they need to set up the alerts. We can do that for you as well.
So on which maybe you covered it, but maybe I added in, take note of it. What cloud platform does LeapFrog cover?
We cover all the major three, AWS, GCP, and Azure. And we are also working, our platform is built in such a way that if your cloud provider has a Terraform schema or a provider, then we can easily integrate into. So we design the platform for any new player or any cloud providers. It's not necessarily, I mean, the top three cover pretty much 80 to 90% of the everyone is there because they have kind of solidified the market for the services and everything. But we also support tier two cloud providers like OVH, DigitalOcean, and all these other providers as well. As long as they have Terraform supported, we can integrate them.
Wow, Terraform has quite a lot of supporters provided. So I guess you cover a lot. Okay. So what will be your final words to the audience?
Well, in terms of the vision for the company, I would say in general, I would say that in general, the space we are in. The reason, I think I touched upon this first as well. The reason this space is gonna heat up. We're only starting now because of the huge AI wave, and there's gonna be more code that's gonna be written than in the last from the inception of code combined in like the next year or two, and it's only gonna exponentially grow because AI is getting better and better. So people are just, products like Lovable and things like that. People just like English is like communication is the new coding language. Like humans will stop writing code. Like you just say it and then it'll become, that's the point we're going. So the problem, what I described now, will only exaggerate itself because when something breaks, nobody knows how to fix it because and even if you know how to fix it, it'll take you longer to fix it because you have to go through the code you're seeing for the first time and solving it. So I think that's the need for what we are trying to achieve. And and I hope we can make a dent in the industry, and then hopefully people will love our products. And at the end of the day, we want to build a product that people love to use. It's just not about solving these issues, but how it looks and feels like UI, UX. People should want to fall in love with the product and like to use it every day. So that's our design language as well. So, but yeah, that's we're really excited. I mean, it's a difficult challenge, but as I said, that's what makes it exciting.
Wow. One thing still sticks with me. If you manually reviewing an AI written code in the middle of crisis, then you've partially lost the battle. I like that code. I like that code. And that's what you guys are doing. I maybe didn't touch on this, but let me ask this final question. If you know, I wanted to close. What is your customer? What's your customer profile? Is there a B2C kind of customer profile that you guys work with?
It's traditionally B2B, but I can also think of like B2C angles where, people might want to just play around with their personal projects, like just, use this. But it will be more B2B where this makes sense because we're talking about revenue saving and everything. So it naturally falls into that bucket. But, in the age of AI, like, there are a lot of one-person companies. People just vibe code something and then, they make like 10K a month on that product. So that in itself is a small business, and then it's a one person running it. So even to that person, revenue is a big thing. So anyone who makes money, our product will help you fix the issues and then save you from bleeding more money. So yeah, I think B2B traditionally, but there could be a B2C angle in the new AI.
Right. So if you're a vibe coder, you are not left out. Okay. All right. Thank you very much, the Kishore. Hope I mentioned your name correctly.
Thanks for having me.
Yeah, thank you for coming today. Viewers, that's going to be at the end of our discussion. So today we went through reactive to predictive, how is AI transforming site reliability engineering. And our guest today has been Sakthi from LeapFrog, and they are doing amazing stuff. I'm going to put their link in the description so you can check them out. You can reach out to them whenever you want to. And don't forget to subscribe and like and tune in for more sessions with industry leaders like Sakthi. Okay, so we're going to end here, and take care of yourself and enjoy your days.